Welcome. Today we are doing notes 9.7, solving without common bases. So between what two consecutive integers will you find log base 3 of 150? So they're asking us 3 to what power is going to give us 150, right? If we set this log equal to x, that's what they're asking us. 3 to what power is 150? Okay, well, that's the 3 to the first is 3, 3 squared is 9, 3 cubed is 27, 3 to the fourth is 81. Oops, what's 3 to the fifth? Right, so that would be 81 times 3, which is 243. Okay, so that's bigger than 150. So that means the answer for what power would be between 4 and 5. So 3 to the fourth power, 3 to the fifth gives me somewhere between 81 and 243. So my answer, again, you're looking for the exponent, the power that makes it work. That's logarithm is the power that works. So I know it's somewhere between 4 and 5. I don't know exactly what it is. Okay, so there is a log key on your calculator, right? But most of them can only do base 10. You'll see the word log. So most calculators, unless you get a fancy one, won't do anything but base 10. So there's ways around that. So since log base 3 to the 150 is not base 10, we're going to use the change of base theorem so our calculators can do this. So if you have log base a of b, right, the change of base theorem would allow me to write this as log base 10 of b divided by log base 10 of a, which is really just log b divided by log a. So I can take a logarithm like log base a of b and change it into base 10 by doing log of b divided by log of a. So use the change of base theorem to figure out what is log base 3 of 150. We're going to change it into base 10 and use our calculator. So this would be log of 150 divided by log of 3. So if you grab a scientific calculator, and if you have your phone, you could turn it sideways, and you do log of 150 divided by log of 3, you get 4.561. So that is the exponent. 3 to the 4.561 would give you 150. So if you typed in your calculator 3 to the 4.561, it would equal 150. So the change of base theorem is extremely nice because it allows you to change any log into base 10 and use your calculator. It actually allows you to change any log into any base you want. It just depends what you're trying to do. So we're going to use it to help us rewrite some bases. So we're going to use the change of base theorem to rewrite the given log into the indicated base. So base 7. So log base 7 of 11 divided by log base 7 of 6. And again, this is the 6, so that goes in the bottom because that's a 6. So base 5 would be log base 5 of 90 divided by log base 5 of 2. Again, this is the base, that's the base, so that goes on the bottom. Now, are we going to use that much? No. It could help you down the road, but usually we're going to be going to base 10 because our calculators can do base 10. So we're going to express as a single log. So this is in base 4. We can write this as a single log. So this is your base, 5. So this becomes log base 5 of 10. So here, your 5 is your base again. So this is going to be log base 5 of 25. So again, that's just getting you comfortable using the change of base theorem. We're going to mainly use it to go into base 10 so we can use our calculators. So let's flip our notes over. So we're going to solve for x, write your final answer in a logarithmic in 2 different ways, and then evaluate your answer using a scientific calculator to round your answer to the nearest thousandths place. So before we get to solving these problems, right, we've been solving problems like 3 to the x equals 27, right? We would rewrite 27 as base 3, so you would get x equals 3. So that's what we've been doing. Those are the problems we had like in 9.2 and 9.3. Now the problem is you have base 3 here and you have base 12. How do you rewrite 12 as 3 to some power? Well, it's 3 to some decimal. I don't know what it is, right? Because 3 squared would be 9, but 3 cubed is 27. So it's bigger than 2 but smaller than 3. Okay, so that's not going to help us. So we're going to use our calculator. But in order to do that, we want to get it into log form first. So we're going to have to kind of work backwards. Okay, so 3 is our base no matter what. So it'd be log base 3. Because so now we're going backwards of 12 equals x. So we're putting it into log form. Right? If you look back to your 9.2 notes, we first talked about logs. Right? We're working backwards now. So now I'm in base 3, but I can change the base into base 10 by doing log of 12 divided by log of 3. That equals x. So there you go. That's one form. There's a second form of writing it. So now I'm going to use my calculator. I'll grab my scientific calculator, do log of 12 divided by log of 3. And when you do that, you should get x is about 2.262, which is what we said. We said it was between 2 and 3. So if I can't change the base, right, I would never do all this work if I could rewrite 12 as 3 to some power. But if I can't rewrite the base, then I'm going to go into log form and change the base and use my calculator. So 5 to the x equals 40, right? I mean, 5 to some power is going to equal 40. I don't know what that is, right? 5 squared is 25, but 5 cubed is 125. So it's bigger than 2, but less than 3. So I'm going to change this into log form. So the good news is 5 is always the base. And the 40 and the x basically just switch spots. So then 40, and this is going to equal x. So now that's one way to write it. I'm going to change it to base 10. So log of 40 divided by log of 5 equals x. There's a second way to write it. Now I can grab my calculator. Again, if it's a phone, you're more likely to turn it, like if it's an iPhone, turn it left so you can get the scientific part. So there's a log button, right? Do 40, do log, divided by 5 and log, and then you should get x is about 2.292. And I'm going to 3 decimal spots because it said round to the thousandths place. Tenths, hundredths, thousandths. That's 3 decimals. So you should be looking at the 4th number depending to determine your rounding. Okay, next example. So we have 6 to the x minus 2 equals 87. Again, it would be nice to rewrite 6 to some power to equal 87, but I don't know what that is. It's some decimal. So I'm going to go into log form. So again, this is the base of the log. So it's log base 6. And the 87 and the x minus 2 just switch spots. So equals x minus 2. Okay, so what I'm going to do, right, is I'm going to add the 2 over. And there we go. Written one way, written a second way. So now how do I figure out what x is going to equal? So I'm going to type this in my calculator. Oh, wait, it's base 6. So I got to change that into base 10 before I try to figure out what x is. So this would be log of 87 divided by log of 6. Then I'm going to add 2, and there we go. So grab your scientific calculator, do log of 87 divided by log of 6. Right? You should get roughly around like 2.4. So around there. And then you're going to add 2. So you're going to get 4.492. So I plug this part here into the calculator first. Figure it out. It should be a little over, should be just under 2.5, around 2.4, somewhere around there. Add 2, and you get 4.49. Okay, next example. Same idea. I can't rewrite 48 as a power of 2. So I'm going to change it into log. So again, the 2 is your base. So this is going to be log base 2, and a 48 and the 2x are going to switch spots. So 48 equals 2x. So I'm going to change this into base 10, right? Log of 48 divided by log of 2 equals 2x. So the easiest way would be to plug this into your calculator. And then when you get that, divide by 2, because we're solving for x and we have 2x. So figure out what that is and then divide by 2. So plug in log of 48, divide by log of 2. You're going to get a decimal. And then divide that by 2. And you should get x is about 2.792. So again, I would plug what I'm circling in red into my calculator first. So do that now. Once you figure out your answer, then divide it by 2 because you're solving for x, and right now I have 2x. So whatever answer you got when you did log of 48 divided by log of 2, you got to cut it in half. And you should get around 2.792. Wait, last 2 examples, a little bit more complicated. Notice those first 4 we did, all of them had a single number, single base with an exponent. Now this has a 3. So I'm going to divide by 3 first to get that 2 to the 2x by itself. So when you do that, you get 27. Same idea. It'd be great if I could write 27 as 2 to some power. Now it is, but I don't know what it is. It's some decimal. So I'm going to go into log form. So again, the 2 here is your base. Same thing for your log function. So base 2. The 27 and the 2x are going to switch spots. They're going to switch sides of the equal sign. So now I'm in log form. Again, I can take my log equation here and turn it into base 10. So log of 27 divided by log of 2 equals 2x. So now I can use my scientific calculator. So I'm going to take my scientific calculator and plug this quotient into my calculator. So log of 27 divided by log of 2. Do that now. Once you get that answer, then I'm going to divide by 2 because I'm solving for x and I have 2x. And when you do that, you should get x is about 2.378. Now, yours could be off a little depending on how many digits you're rounding to when you do the division, but it should be very close to what I have. It should be not that far off. And then the last example, same idea. I want 6 to the x minus 2 by itself, so I'm going to divide both sides by 4. So I'm going to get 16. So again, it would be great to rewrite this so both sides would have the same base, but that's not going to happen without decimals. So I'm going to go into log form. So here's your base of your log. Log base 6. The 16 and the x minus 2 are going to switch sides of the equal sign. So I'm there. So I'm going to change this here into base 10. So log base 16 divided by log base 6 equals x minus 2. Now I'm going to add 2. Okay. So now, with my scientific calculator, I can do log of 16 divided by log of 6. So do that now. Log of 16 divided by log of 6, you're going to get a decimal. Once you get that answer, then add 2 to the answer, right, plus 2, and it should be about 3.547. So again, plug this part into the calculator, log of 16 divided by log of 6. Gives me a decimal, then I put plus 2, and I should get a number extremely close to about 3.547. So the whole idea behind this worksheet or this set of notes is when you can't get the same base, you can always go into log form, use the change of base theorem, and use your calculator. Now, we will try to avoid that as much as possible. But sometimes it's going to happen, especially when you start applying logarithms to real world problems. They often don't come out to nice whole numbers, so you have to use some type of electronic device to help you. So again, change of base theorem. We're usually just going to go to base 10. So if you have log base a of b, it becomes log b divided by log a. That's usually the base you're going to change it to, because that's what most scientific calculators have. Now, if you get one of those fancy calculators, like a TI-83, 84, they'll do any base you want. So you don't have to change the base. But not all of us have those calculators. So please make sure you answer the essential question, right? As you write your summary, 3 to 5 sentences long. Once you finish that, you're done with your notes. Have an amazing day.